Good morning. The next wave that we are going to discuss is stationary waves. Stationary waves are produced by superposition of two progressive waves of equal amplitude and frequency traveling with the same speed but in opposite directions. So here we are. We have a simple diagram of a stationary wave or a standing wave. We have here nodes and antinodes. Nodes are the points where there is no displacement at any time. And in between the nodes are positions called antinodes where the displacement has maximum amplitude. In this video, a blue wave and a green wave are of equal amplitude and frequency. The blue wave is traveling to the right, while the green wave is traveling to the left with the same speed. You can see there. Along the way, both waves superpose or interfere, so there will be nodes and antinodes formed. We can see here, there will be times when the superposition result in zero displacement. But there will be times when the amplitude is maximum. Here, this is where the amplitude is maximum. The maximum amplitude is twice the amplitude of each traveling wave. So we can see here that there is changing amplitude when we have a standing wave or a stationary wave. There, the superposition is shown by the red wave. There are two types of stationary wave. The first one is the reflection of waves at a fixed end. So the reflected end here is fixed. And then the reflected wave later will be inverted. So there will be a phase change of pi. So here we have a pulse of wave coming to the reflected end, and when it is reflected back, the phase will be inverted like this. This is a stationary wave with fixed end. And the second type is the stationary wave with a free end. Here, when we have a pulse, it is going to the reflected end, which is free to move. Then there will be no phase change, or there will be zero phase change at the reflected end. Now we are going to derive the equation of displacement of a stationary wave with a fixed end. I have a diagram here. Suppose we have a wave that travels from the source of oscillation. This is the source of oscillation. And it reaches a reflected end which is fixed. It cannot move. That is at a distance of L from the source. At the fixed end, the wave is reflected with equal amplitude, frequency, and speed, so that a stationary wave is formed. At point P of a distance x from the reflected end, there will be a displacement of wave, and we can derive the equation of the displacement at this point P. What we have to pay attention to is that we have the oscillation time of the source, and we have the oscillation time of the reflected end. And of course, the time of oscillation of the source will always be greater than the time of oscillation of the reflected end. So here I can say that the oscillation time of the source will be the oscillation time of the reflected end plus the time needed by the wave to travel from the source to the reflected end, which is equal to L over the speed of the wave. Yeah, so here we have T source equals T reflected N plus L over V, or when we want to find the T of the reflected N, it will be equal to the T source minus L over V. Remember, L over V is the time needed by the wave to move from the source to the reflected end. Remember that stationary wave is the superposition between two traveling waves. In this case, the traveling waves which are superposed is the incoming wave, the incident wave, and the reflected wave. They both have the same amplitude, the same frequency, and the same speed, but in opposite direction. And for a fixed and stationary wave, the reflected wave is inverted. So there is a phase angle change of pi. So when we want to see the equation, the displacement of the incident wave will be written as A times the sine of omega times T source minus K times L minus X. Remember the equation of the traveling wave that we discussed before. Yeah, this is L minus X. So the incident wave will have a displacement of A times omega times T source minus K times the distance traveled from here to P is L minus X. And the wave travels from the left to the right. So we have negative sign here in front of K. But the reflected wave will have the equation of displacement of negative A times the sine of omega times T source minus K times L plus X. This is negative because, as I told you before, that there is a phase change of pi. So the amplitude will be negative. Let's say that this is P and this is Q. And we want to add them up together because there is a superposition between both waves. So the displacement of the stationary wave will be the displacement of the incident wave plus the displacement of the reflected wave. And it will be A times the sine of P plus negative A times the sine of Q. And we will have this equation in mathematics. I'm sure you have already got the equation. Sine P minus sine Q is equal to 2 times the cosine of a half P plus Q times the sine of a half P minus Q. And P plus Q will be equal to omega times T source minus KL plus KX plus omega times T source minus KL minus KX. So it will be equal to 2 times omega TS minus 2 times KL. While P minus Q is equal to omega TS minus KL plus KX minus omega TS minus KL minus KX. So we can see that omega TS minus omega TS will be 0. Minus KL minus KL will also be 0. So there is only 2kx left. So the displacement of the stationary wave will be the displacement of the incident wave plus the displacement of the reflected wave, which we have A times 2 times the cosine of a half P plus Q. P plus Q was 2 times omega TS minus 2 KL times the sine of a half P minus Q. P minus Q was 2kx. So multiplied by a half, it will be kx. And we want to change this T source into T reflected n plus L over V. So omega is multiplied by T reflected n, omega T, plus omega multiplied by KL is omega multiplied by L over V is equal to KL. So here we have omega times T reflected plus omega times L over V, which is equal to plus KL. And we have negative KL there, multiplied by the sign of KX. So our equation for a stationary wave with fixed end is 2a times the sine of kx times the cosine of omega times t from the reflected end. And this is the displacement of a stationary wave of a point of a distance x from the reflected end or fixed end. So x must be from the reflected end or from the fixed end in this case. And 2a times the sine of kx is the amplitude of the stationary wave. So we can see here that the amplitude is a function of x. So it will change as x changes. As we can see in the video before, that the maximum amplitude later will be twice the amplitude of the traveling wave. This a is the amplitude of the traveling wave. And the amplitude keeps on changing according to x, where x is the distance from the reflected end. When stationary wave is formed, there will be antinodes and nodes formed, and we can formulate the distance from any nodes or antinodes formed from the reflected end. The point of reference is from the fixed reflected end. Remember that. So this is node, the first node. The first node is at x equals 0. Yeah, so x is the distance from the fixed end. And the second node will be formed at x equals a half lambda. This is a half lambda. The third node will be formed at 1 lambda there, and so on. So we can conclude that these are the even number multiplied by 1/4 lambda. So we can formulate the nth node, or in your book, this is Sn, is equal to 2 times n minus 1 times lambda over 4. What about the antinodes? Antinodes 1, the first antinodes, will be formed at 1/4 lambda. This is 1/4 lambda. The second antinode will be formed at 3/4 lambda here. And the third one is 5/4 lambda, and so on. So we can formulate, this is the odd number multiplied by 1/4 lambda. So nth antinode, or in your book, this is Pn, is equal to 2n minus 1/4 multiplied by lambda. For a free and stationary wave, I have this diagram. See, at the reflected end, there will always be antinode because this end is free to move. So here, there will always be antinode. In the previous fixed and stationary wave, there will be node in the reflected end. But in the free and stationary wave, there will be antinode here. Yeah, so here we know that when we have free and stationary wave, the reflected wave is not inverted, so there will be 0 phase change. But still, I have T source, which is greater than T of the reflected end always. And then this equation still applies. T source is equal to T reflected end plus L over V. Yeah, And then I can write down the equation of the incident wave as A times the sine of omega t source minus k times L minus x. And the reflected wave will be A times the sine of omega t source minus k times L plus x. This will be positive because, as I told you before, that there is a zero phase change. So I can assume this to be P and this to be Q. So we can add them up. So I have the displacement of a stationary wave, the displacement of incident plus the displacement of the reflected wave, A times the sine of P plus the sine of Q, and the equation will be A times 2 times the sine of a half P plus Q times the cosine of a half P minus Q. And remember that P plus Q was this, 2 times omega ts minus 2kl. P minus Q is 2kx. So I will change this. So I have the displacement of a stationary wave is 2a times the cosine of kx times the sine of omega t reflected. This is for a point of a distance x from the free reflected end. Remember that our point of reference is the reflected end. And these 2a times the cosine of kx is equal to the amplitude. As we discussed before, when we deal with a stationary wave, then the amplitude is changing when x changes, and the maximum amplitude will be twice the amplitude of the traveling wave. And about the distance from the nodes and the antinodes from the reflected end, we have to see that the point of reference is always from the free reflected end. And here we can see that in the reflected end, there will always be antinode. So the first antinode is when x equals 0. The second one will be formed when x equals a half lambda and so on. And we can make a generalization that this is an even number multiplied by 1/4 lambda. So we can formulate the nth antinode, or Pn in your book, is 2 times n minus 1 over 4 lambda. What about the nodes? The first node will be formed at x equals 1/4 lambda. The second node will be formed when x equals 3/4 lambda from the reflected end, and so on. So this is an odd number multiplied by 1/4 lambda. So nth node will be 2n minus 1 over 4 lambda. In your book, this is Sn. To summarize the equations that we have derived, you can see it in the table in your book. We have two types of stationary wave, fixed end and free or open end. For a fixed end stationary wave, the equation will be y equals 2a times the sine of kx times the cosine of omega tp. This a is the amplitude of the traveling wave that is forming the stationary wave. This x is the distance from a point from the reflected end. This Tp is the time from the reflected end. And so for the free or open end, y is equal to 2a times the cosine of kx times the sine of omega Tp. Yeah, a is the amplitude of the traveling wave. X is the distance from a point to the free end or to the reflected end. Tp is also the time from the reflected end. So in this equation, we can see that the amplitude is 2a times the sine of kx. Yeah, as is the amplitude of the stationary wave, while this a, once again, this is the amplitude of the traveling wave. Yeah, and so here 2a times the cosine of kx is the amplitude of the stationary wave. So we can see that a stationary wave has changing amplitude. It depends on the x. Yeah, and x is the distance from a point to the reflected end. And you have Pn here. P is the antinode. S is the node. Yeah, so this is the nth antinodes. This is the nth nodes. And this n is from 1 and so on. Yeah, so you can see the equations from this table. Now I will discuss 3 worked example, and the first one is number 3, page 159. The 10th node formed in a stationary wave is at a distance of 1.52 meters from the free end. I would like to draw the diagram. Yeah, the frequency of the wave is given and we want to determine the speed of the wave. We draw the free end here, and there will always be an antinode at the free end. So this is the first antinode. This is the first node. First, second, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th. The 10th node is at a distance of 1.52 meters from the free end. And this will be how many lambdas? 1 lambda is 2 loops like this. Yeah, so from this point to that point is 1 lambda. 2 lambdas, 3, 4, and from here to there is 3/4 lambda. So total we have 4 3/4 lambda, and it should be equal to 1.52 meters. So here I can find that lambda is equal to 0.32 meters. Or if you want to memorize the equation that we have derived, Sn, or the nth node, is given by the formula or the equation of 2n minus 1 over 4 lambda. If you use this equation, you will find that lambda is equal to 0.32 meter. But if you cannot memorize this, you can easily just draw the stationary wave. And remember that at the free end, there will always be antinode because this is a free end stationary wave. So when we have got lambda and we are given the frequency, then we can find the speed by using this equation, lambda multiplied by frequency. So we have 16 meter per second. For question B, we want to find the equation of the stationary wave. And for the free or the open end, we have y equals 2a times the cosine of kx times the sine of omega t. And k is 2 pi over lambda. Remember, lambda is 0.32. So it will be equal to 25 pi meter to the power of minus 1. And the omega here is 2 pi f. So it is 2 pi multiplied by 50 equals 100 pi radian per second. So the equation will be 2a times the cosine of 25 pi x times the sine of 100 pi t. We don't know the amplitude of the traveling wave, so just let it be. Now, example number 4, page 159. I have a string 75 centimeters long and it is fixed at one end. The other end is moved up and down with a frequency of 15 Hertz. I want to draw the string. This frequency gives a stationary wave pattern with 3 complete loops. So this is 1 loop, 2 loops, and 3 loops. 3 complete loops. It means this is 1.5 lambda, 3 over 2 lambda, equals 75 centimeters. And we can calculate lambda, which is 50 centimeters. And we are given the frequency, 15 Hertz. So from there, we can use phi equals lambda multiplied by frequency. It is equal to 7.5 meter per second. Next is the problem set number 7, page 162 to 163. A piece of rope GS of length 2 meters is hung vertical with S as the free end. G is then oscillated with frequency of 6 Hz and the amplitude of 5 centimeters. The speed of the wave is 1.8 meter per second. You want to calculate, the first one is the distance between the third node from the free end S. So I draw a diagram like this. This is G. G is the source of oscillation. And then S is the free end. The amplitude is 5 centimeter, the frequency is 6 Hz, and the speed is given. So from these data, I can find the lambda, which is V over F. And the lambda is 0.3 meters. So if I want to find the distance between the third node from the free end, this is the first node, the second node, the third node. So the third node from the free end is 1 and 1/4 lambda. Or you can use this equation. The third node will be 2 times 3 minus 1 over 4 lambda. Yeah, so this is 5 over 4 lambda. And if we calculate, this is 3 over 8 meters from S. Yeah, from the free end S. The second question is about the distance between the second antinode from the wave source G. I can use the equation. The second antinode will be 2n minus 2 over 4 lambda. And this n is equal to 2 second antinode. And I calculated this to be 0.15 meter. But remember, this is from S. The question is from the wave source G. So if I know that the length is 2 meters, while the second antinode is 0.15 meters, 0.15 meters from S, then from G it will be 2 minus 0.15 meter. It will be 1.85 meters. Question C. The displacement of a point at a distance 1 meter from G when G has been oscillated 2 seconds. The displacement of a free and stationary wave is y equals to a times the cosine of kx times the sine of omega t. So we have to find k, 2 pi over lambda. It is 2 pi over 0.3 meter to the power of minus 1. And omega is 2 pi f equals 2 pi multiplied by 6 in radian per second, 12 pi radian per second. And this x is 1 meter from G. So remember that we have to always state x from the free end. So if it is 1 meter from G, GS is 2 meter, then from S it will be 2 minus 1. And this T is also T from the reflected end. So we should find T from the reflected end, which is TG minus L over V. So T of the reflected end will be 2 minus, the L is 2, V is 1.8 meter per second. So I have 1.6 over 1.8 seconds. Now we will substitute those quantities into this equation. The amplitude is 5. The K is 2 pi over 0.3. This X is 2 minus 1. As I told you before, we have to state X from the reflected end. And this time should be time of the reflected end. So this is 12 pi multiplied by 1.6 over 1.8. This becomes 10 times the cosine of 20 pi over 3 times the sine of, this is 32 pi over 3. And the cosine of 20 pi over 3 is equal to the cosine of 6 pi plus 2 pi over 3. So it will be equal to 10 times the cosine of 2 pi over 3, while 32 pi over 3 is equal to 30 pi over 3 plus 2 pi over 3. So it will be equal to the sine of 2 pi over 3. So the result will be minus 2.5 times the square root of 3 centimeters. Now you have to do yourself the example problems that I have discussed. Number 3 and 4, page 159. Number 7, page 162 until 163. Try to do it yourself, but if you have any doubts, you can see my video. And then number 8, 9, 10, page 163 to 164. Please try to solve the problems and then scan your work and submit by uploading it to Schola. And then your homework for next week, you have 6, 15, 16, 17, 18, 19, 20, 6 multiple choice questions related to the stationary wave. If we can meet at school next week, then I will check your work. But if you still learn from home, then submit by uploading it to Schola on Tuesday next week before 10 a.m. Yeah. Once again, if you have any questions, you can contact me in those numbers. Thank you for your attention. I hope this video is useful.